Welcome to the Bare Metal Cyber Security Plus podcast. This series helps you prepare for the CompTIA Security Plus exam with focused explanations and practical context. For a companion study guide, check out the Achieve CompTIA Security Plus 701 Exam Success by Dr. Jason Edwards. It is the most concise and complete Security Plus guide on the market, built for busy professionals who want to pass the exam fast and on their first try. You can find this book and others at cyberauthor.me. In this episode, we're focusing on port security and the authentication protocols that support it, specifically 802.1x and the Extensible Authentication Protocol. These technologies help ensure that only authorized devices can access the network, and they form the backbone of identity-based network control in both wired and wireless environments. Let's start with the essentials of port security. At a basic level, port security refers to controlling access at the physical or logical switch port. It's a way of enforcing identity and trust before granting network connectivity. Without port security, any device that connects to a network port may receive an IP address and start sending traffic, potentially bypassing firewalls, intrusion detection, and access control. One of the most effective port security protocols is 802.1x. This standard defines how network access is granted based on authentication at the port level. Instead of letting devices connect freely, the switch or wireless controller waits until the user or device has been authenticated before allowing access. 802.1x works by dividing the communication path into three roles: the supplicant, the authenticator, and the authentication server. The supplicant is the client device trying to connect, like a laptop or smartphone. The authenticator is the network device controlling access, usually a switch or wireless access point. The authentication server is typically a remote authentication dial-in user service, or RADIUS server, that validates credentials. Here's how it works in practice. When a user plugs into a network port, the switch immediately puts the port into a holding state. The user's device must then provide authentication credentials, such as a username and password, a digital certificate, or even biometric data, through the 802.1x protocol. The switch forwards this information to the RADIUS server, which checks the credentials and returns a decision. If the authentication succeeds, the port is opened and the user gains access to the network. If it fails, the port remains closed. The security benefits of 802.1x are significant. It prevents unauthorized devices from accessing the network, even if they're plugged into a live port or connected to a wireless network. It supports identity-based access control, so different users can receive different levels of access depending on their credentials. And it enables centralized logging and policy enforcement, improving visibility and compliance. 802.1x is widely used in enterprise environments, especially those that need strong control over who connects to the network. It's common in universities, hospitals, government offices, and corporate campuses where the risk of unauthorized access is high. Now let's talk about the Extensible Authentication Protocol, or EAP. EAP is not a specific authentication method. It's a framework that allows many different methods to be used during the 802.1x process. It was designed to be flexible, allowing authentication to be based on passwords, certificates, tokens, or smart cards. There are multiple versions of EAP, each with its own strengths and use cases. EAP TTLS uses transport layer security and is considered one of the most secure versions. It requires both the client and the server to have digital certificates, enabling mutual authentication. This version is commonly used in high-security environments where certificate management is feasible. EAP TDL and PEA are other common implementations. These versions create a secure tunnel using certificates but allow the client to authenticate using credentials like usernames and passwords inside the tunnel. This approach is easier to deploy than full certificate-based mutual authentication and is popular in large-scale deployments where distributing certificates to every device may not be practical. The flexibility of EAP allows organizations to choose the method that best fits their environment. Whether they prioritize ease of use, scalability, or cryptographic strength, EAP provides a foundation that supports a wide range of requirements. Together, 802.1x and EAP enable dynamic, secure access control at the network edge. They prevent unauthorized devices from connecting, enable different policies for different user groups, and improve accountability by tying access events to specific identities. As you prepare for the Security Plus exam, be ready to identify the roles in the 802.1x architecture, describe how EAP supports various authentication methods, and explain the value of port-level access control. You may be asked to compare EAP versions, evaluate scenarios for certificate-based authentication, or recommend a solution for preventing rogue device access. Focus on access control, visibility, and the integration of authentication into the network layer. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.